Next, we're going to look at the hypothesis test of a population proportion. Consider an example where the test examines a proportion of the population, such as the proportion of people who are graduate students, for example, 20%, the percentage of something that is a proportion of the whole. When examining the proportion of a sample, there is one parameter. It's P with a little hat over it. Again, some people put the bar over it, but I'm going to use the hat notation. So the opposite of that population is 1 minus P hat. If, say, in a survey of 45% of the respondents chose one particular political candidate, P hat is 45% or 0.45. 1 minus P hat is 55% or 0.55. When looking to see if the population proportion is the same as some hypothesized value, the z-test will always be used. And the reason is because we will not have a standard deviation. We're not going to have two parameters that need to be estimated. From the previous slide, 45% of a survey found a particular candidate popular. The goal is to see if this is different from 50%. Below is the hypothesis test. Null hypothesis is that P hat is equal to 0.5. The alternative hypothesis is that P hat is not equal to 0.5. Next, we're going to compute a z-statistic using the following formula. P hat minus P naught, which is P0, divided by the standard deviation of P hat. The standard deviation of the proportion is a little bit different calculation. It is basically going to be the square root of P hat times 1 minus P hat over n. It's not a difficult calculation. I'm using the example from before where the population proportion was 45%. Assume the sample is 500. Then the following can be calculated. Sigma of P hat is going to be equal to the square root of 0.45 times 0.55 divided by 500, which is equal to 0.2475 divided by 500, or 0.000495. Finishing our z calculation from that z formula up in the top, we have 0.45 minus 0.50. We're comparing P hat to P naught, or P0. That'll give us a negative 0.05, and we divide that by that standard deviation of P hat. So therefore, using that example, it's not so difficult. We have z equal to negative 0.05 divided by 0.000495, which is equal to negative 101. Next, we can compute the p-value using Excel. Since this is a z value, we use norm.s.dist of negative 101, true for cumulative, and that's going to be a very, very small number. It's essentially 0. This is a two-tailed test, so the alpha needs to be cut in half. But this example p-value is extremely close to 0, and therefore we can reject the null hypothesis. In another example, given a survey of 52% of the respondents preferred a particular cereal, the marketing department wants to know if more people prefer this cereal and if this value is statistically significant with a sample of 250. First, we compute p hat, which is 52% of 250, so that's 130. Therefore, 1 minus p hat is 48%, or 120. We'll then compute z and sigma. Z, p hat minus p naught over sigma of p hat. And we know that sigma of p hat is going to be the formula p hat times 1 minus p hat divided by n. And we take the square root. Taking the square root of 0.52 times 0.48 over 250 is going to be equal to 0.2496 over 250, which is equal to 0.000998. Take the square root and you get 0.031. We take our z calculation and we do 0.52 minus 0.50, which is 0.02. And we divide that by our 0.031, which gives us a 0.64. So the z value is going to be 0.64. Now that the z value is computed, the p value is computed using Excel. Again, since it's 0.64, we're going to do 1 minus because it's going to be on the right side. And this is going to give us a result of 0.26. Since the alpha is 0.05, this is a one-tail test. There's no need to have the alpha. So recall our rejection rule, which we have here on the right. Since 0.26 is greater than 0.05, we do not reject the null hypothesis. Therefore, we have no evidence to support the fact that the product is preferred by more than 50% of the people. A quick summary can be developed for this proportion hypothesis test. We have our null and alternative hypothesis, both for a lower tail, upper tail, and two-tail test. We compute our test statistic of z is equal to p hat minus p naught over sigma of p hat, and that's the same for all of them. If the p-value is less than alpha, we reject h0. And for a two-tailed test, if the p-value is less than or equal to alpha over 2, we reject h0. Alternatively, again, we could use the z critical values we spoke about earlier to do the same thing.